Algebra 2, this is our first review for the polynomials quiz. We will have quiz test in this particular unit, so this is our first quiz. Just real quickly, things we did: classifying polynomials, the degree, the leading coefficient. Those are things we did very beginning. Working with monomials, binomials, trinomials, adding, subtracting, and multiplying those. We focus on multiplying, but there'll be a couple examples today of adding. You know how to do that. How to expand certain things. This one, there are formulas for each of these. You can either know the formulas or know how to derive them. So for example, in this one, if you don't know the formula, that's a plus b times a plus b. Or this one right here with the cube, that's a plus b times a plus b times a plus b. If you didn't know the formula, you can derive it. From there, we moved into factoring. So factoring had several methods. Greatest common factor. If you see that, do that up front, and that will simplify what you're working with. Difference of two squares. That was a formula. You need to know the formula and how to recognize it when it shows up in a problem, okay? Factor by grouping, only method we have when you've got four terms, you need to factor. Quadratic trinomials, when the leading coefficient of the x squared is 1, when the leading coefficient of the x squared is not 1. And then sum of difference of cubes. You should have marked in your book that you needed to know this, okay? We talked about SOAP as an acronym for how to do that. Then after that, we moved into solving polynomials, where factoring was the key thing that you needed to be able to do in order to solve polynomials. From there, we moved into dividing polynomials with long division, terms that are related to division, the dividend, the divisor, the quotient, the remainder, how those play into division with polynomials. And then the last thing we did, synthetic substitution, and then that step about when things are missing. How do you represent that with a zero placeholder? Okay, let us move into the review. Simplify by performing the indicated operation. In this one, please do not multiply. There is a minus sign right in here, so this is pretty straightforward. This is x squared. And then if I gather like terms, that's going to be minus 2x squared, 2x minus 3x minus 7 minus 4. So this is going to leave me with minus x squared minus x minus 11. That is the answer when I subtract these two polynomials. Next one is a binomial multiplication, so we can use the FOIL method. The first two things multiplied, that is 6x squared. The outside terms multiply, that is minus 8x. The inside terms, minus 9x. And then the last terms give me positive 12. Combining like terms, 6x squared minus 17x plus 12. And we move into problem 3. This is a binomial times a binomial. If you don't remember the formula, just write this as x plus 2 times x plus 2. So that is x squared plus 2x plus 2x plus 4. This becomes x squared plus 4x minus 4. The next one is an expansion of something that is cubed. We do have a formula. A minus b cubed is a cubed minus 3a squared b plus 3ab squared minus b cubed. So in this case, if I'm going to use this formula, I'm applying it to this operation right here. So my a in this formula, a is 2x and b is 1. And it looks like this is a minus b cubed. So I'm going to have 2x cubed minus 3, 2x squared times 1 plus 3, 2x times 1 squared minus 1 cubed. This becomes 8x cubed, and this is If you look at this term right here, that is 4x squared. So this becomes minus, back up, minus 12x squared plus 6x minus 1. Okay. Now, if you had trouble with that and memorizing the formula, you can always just do it by multiplying everything out the binomial. So you've got 2x minus 1 times 2x minus 1 times 2x minus 1. If I multiply these first two together, I get 4x squared, and that's minus 4x plus 1 times 2x minus 1. And now what has to happen, I can either do a chart or I can just distribute. Everything has to be multiplied. So this 2x needs to multiply everything in that parentheses. So if I did that, I would get 8x cubed minus 8x squared plus 2x. And then this negative 1 needs to multiply everything in that first parentheses. So minus 4x squared plus 4x and minus 1. Combining like terms, this would all give me, what, 8x cubed minus 12x squared plus 6x minus 1. So that is the same answer that you see that I got right up here. So two ways of working that particular problem. If I move on to number 5, multiplying two trinomials. We talked about one of the best ways of doing this is to organize yourself a chart. Okay, so it doesn't matter which one goes vertical, which one horizontal. So if I had x squared, 2x, and minus 3, and I'm going to multiply that by 2x squared, x, and 4. Okay. So if I do this in a chart, when I multiply everything together, x squared times 2x squared, this is going to give me 2x to the 4th. X squared times x is x cubed. X squared times 4 is 4x squared. 2x times 2x squared is 4x cubed. 2x times x is 2x squared. 2x times 4 is 8x. Negative 3 times 2x squared is negative 6x squared. Negative 3 times x is negative 3x. Negative 3 times 4 is negative 12. And what you will see when you do this is you get things that need to be combined, and they all line up. Okay, so that one is a little bit hard to see. Let me just go back to green here for this one. So you see the terms that can be combined now. So this final answer is 2x to the 4th, and then my x cubes, so that is 5x cubed. And it looks like I have, what, 0x squared terms. So plus 5x minus 12. Okay. Number 6, I've got two binomials that are being multiplied. And furthermore, you could just multiply these out, or you could recognize this is the same as a minus b times a plus b, which is a squared minus b squared. That's the difference of squares. So I could just say, I know the answer right off is going to be 2x squared that's 4x squared minus 9. That's going to be my answer. If I did not recognize that, I can just FOIL this. So the first two terms, that's x squared. The outside terms, so plus 6x. The inside terms, minus 6x minus 9, so 4x squared minus 9. Either way, you get that same final answer. Problem number 7, you are factoring polynomials and giving the real number solution. Okay, so factor completely and give the real number solutions to this particular problem. So let's look at the first one. X cubed plus 8 is equal to 0. To factor this completely, this is the sum of cubes. So a cubed plus b cubed is a plus b, and then a squared minus ab plus b squared. So in this case, this is going to be x plus 2, x squared minus 2x plus 4. All of that equals 0. And so when I try to find the real solutions to this one, if you look at the first one, so when x plus 2 is equal to 0, that means x equals negative 2. And then if I look at x squared minus 2x plus 4 is equal to 0, but if I look at the discriminant, b squared minus 4ac, that's going to be negative 2 squared minus 4 times 1 times 4. That is 4 minus 16 equal negative 12. The discriminant is negative. Those roots will be complex. So this is the only real solution. If you had been asked to find all solutions, you would need to use the quadratic formula here for this part, and you're going to get 2 complex roots here. Okay. Let's look at the next one that I see. So the next one over here, number 2, quadratic. I'm hoping that factors. So I need 2 numbers that multiply to negative 32 and add to give me a negative 4. Okay. So if I look at that, if I look at an 8 and a 4, they multiply to 32. If the 8 were negative, that gives me a negative 32. They add to negative 4. This can be factored as x minus 8, x plus 4 is equal to 0. Set each factor equal to 0. That means x is equal to 8 or x is equal to negative 4. Those are your 2 real solutions for this one. Number 3. When I look at this, the first thing I see, there is a greatest common factor. There's a greatest common factor of 2x squared. When I factor out a 2x squared, I'm left with x squared minus 4 is equal to 0. What you see in parentheses is the difference of 2 squares. So this can all be written as 2x squared, x minus 2, x plus 2 equals 0. Now, if I set each factor equal to 0, I will get my solution is that x is equal to 0, 2, or negative 2. Those would be all the solutions. Okay, so 3 solutions to this particular one. If I look at number 4, the immediate thing when I recognize this is not a quadratic, but it is in quadratic form, because I see an x to the 4th and an x squared here. So I factor it just like I would a quadratic, which means I need to look for 2 numbers that multiply to 36 and add to negative 13. That's going to be a 9 and a 4. If both those numbers are negative, you get multiplication to 36 and addition to negative 13. So I can write this as x squared minus 9 times x squared minus 4 is equal to 0. Then I recognize both of these are perfect squares, or difference of squares. So this is x minus 3, x plus 3, x minus 2, x plus 2 equals 0. That is the complete factorization. Now to solve it, you set each of those equal to 0. You get 3, negative 3, 2, negative 2. There are 4 solutions to this particular equation. Number 5. So I see 4 terms there. The only way I've learned to factor something like this so far is by grouping. So I look at those first 2 terms. What do they have in common? They have an x squared. So it's x squared, and I'll be left with what? 2x plus 3. If I look at the next 2 terms, they have a 7 in common, and I'm left with 2x plus 3 equals 0. So this gives me x squared plus 7 times 2x plus 3 equals 0. If I set each of these equal to 0, x squared equal -7. When I solve that, I'm going to get a complex solution. So there are no real solutions to this one. When I set 2x plus 3 equal to 0, then 2x equal -3, x equal -3 halves. That is the only real solution to this equation. Looking at the next one, I have a quadratic, but there is a number other than 1 in front of the x squared term. So in this case, I need to look for two numbers that multiply to give me 6 times 2, which is 12, and add to give me a 7. Those numbers are 3 and 4. So I will write this as 6x squared plus 3x plus 4x plus 2 equals 0. And if I look at the first two terms, I factor out a 3x. So I get, 2x plus 1. And then I can factor out a 2. And I'm left with 2x plus 1 equals 0. So 3x plus 2 times 2x plus 1 equals 0. Set each of these factors equal to 0, and you will come up with x equal -2/3 or -1/2. Those are the two solutions to this polynomial equation. Number 7, find the quotient using long division. Okay, so quotient using long division, I've got 4x cubed plus 4x squared plus 5x plus 18, and I'm dividing that by 2x plus 3. So the way you do this, just look at this 2x. What do I multiply 2x by to get 4x cubed? That's going to be a 2x squared. Now let's do that multiplication, and I get 4x cubed, and then I get plus 6x squared. So the next step in long division, subtract all of that, and then your x cubed terms go away, and I get -2x squared. And so now I look at it, what do I multiply 2x by to get a -2x squared? That looks like that's going to be a -x. So when I do that multiplication, I get -2x squared minus 3x. So then I need to bring down this 5x here. And then the next step is you subtract all of that. So this gives me 8x plus 18. And then what do I multiply 2x by to get an 8x? That is a 4. So then I get 8x plus 12. Subtract all of that. 18 minus 12 is 6. So my final answer is 2x squared minus x plus 4 plus 6 divided by my divisor, which is 2x plus 3. Now let's look at the next one, 3x plus 1 dividing into 3x squared plus 7x plus 2. So 3x plus 1, divide that into 3x squared plus 7x plus 2. What do I multiply 3x by to get 3x squared? That is simply an x. So I do that, I get a 3x squared. And then when I multiply the 1 by x, I get x. And then I subtract those, and I will get 6x plus 2. What do I multiply 3x by to get 6x? That is a 2. So then I get 6x plus 2. When I subtract that, I get 0. So there's no remainder. So in this one, when you divide 3x squared plus 7x plus 2 over 3x plus 1, your answer is x plus 2. From there, we move into problems with synthetic division. Okay, with synthetic division, one of the keys, if I look here, that's an x minus 3. So I'm going to set this up. What goes outside the synthetic division is a 3. And then I just need to write the coefficients. So the highest coefficient is 1. That goes with my x cubed. And then there is a negative 1. That goes with my x squared. There's a positive 1 that goes with my x term. And there's a negative 21 that goes with my constant. So everything is accounted for. First step, bring this 1 down. 3 times 1, that's 3. 3 minus 1 is 2. 3 times 2 is 6. 6 plus 1 is 7. 3 times 7 is 21. Add that to get 0. And if you look at it, this corresponds to my x squared, my x, and my constant. So when I do this division in number 9, my answer is x squared plus 2x plus 7. Number 10, set it up the same way, but negative 7 goes outside the synthetic division because I'm testing if x plus 7 is a factor or negative 7 is a root. And then I need to write down the coefficient. So I've got 1. That is my coefficient of my x to the 4th. So I'm going to need an x cubed, an x squared, an x, and a constant term. So 1 is the coefficient of x 4th. 7 is the coefficient of x cubed. 5 is the coefficient of x, and 35 is the constant. So I need to put a 0 there because there is no x squared term. If I bring this 1 down, 1 times negative 7 is negative 7. Add those to get 0. Negative 7 times 0 is 0. Add that to get 0. Negative 7 times 0 is 0. Add that to get 5. Negative 7 times 5 is negative 35. Add that to get 0. And if I look, how do I read this answer? This is my x cubed term, and this is my x squared, my x, and my constant. So the answer to this is simply x cubed plus 5. And that is it. That's the end of the review.